Yes, a very good day to you and yours. This is 300 Plus Academy. Um, Here again with mathematics, but this time around we'll be looking at indices. I am Adeyemi Abiodun, the lead tutor at 300 Plus Academy. So without wasting much time, let's get into it. Okay, we're looking at indices. When we say indices is a way of representing recurring numbers or terms. Take for instance, like we have here, we have 2 times 2 times 2 times 2. So you see 2 reoccurring 4 times, and that gives us 2 raised to the power of 4, where 2 is the base, and then 4 is the power, or what we call index, which is the plural form of indices, and as well we can call it exponent. So that is just indices. It's a way of representing recurring numbers or terms. However, there are laws that governs indices. There are laws that governs how we deal with indices. And looking at the board, we have about 6 laws. Those are at least the basic ones. The first one is the multiplication law, which states that if we have the same base, irrespective of what the index or the exponent or the power is, multiplying each other, we are going to add. If we are dividing terms with the same base, then we are going to subtract the index. And what we have here is what we call, the third one is what we call product power law. Product power law. In the case of product power, you can see A was raised to power m, A was raised to power m, and then we have a power n on the outside of the bracket. So what that means is that the powers or the index will multiply each other. So m times n, that's going to give us mn. And of course, the fourth law talks about negative index. When you have a negative power, the negative power is going to give you inverse of, that's 1 over a raised to power m. So which means if I'm having, let's say, 2 raised to power minus 3, this negative sign A as the power is going to give me 1 over 2 raised to power of 3. Of course, 2 raised to power 3, that is 8. So that's that. Then the next one, the fifth one, talks about law 5 talks about fractional index. In this case, we have a raised to power m over n. You need to understand that the denominator of your index of your power, the denominator is going to form the root. Like you can see here, n roots. You have n roots. A, everything raised to the power of the numerator. So which means that if I have, for example, 8 raised to power 2 over 3, I expect the denominator, which is 3, to form the root. So that is going to be cube root of 8. Whatever I get raised to the power of 2. Cube root of 8 is 2. 2 raised to power 2 or 4. And lastly, we talk about zero index. Anything raised to power 0 is 1. Even 1,000 raised to power 0 is 1. And that ends that about that. That's a run through of the laws that governs indices. So without much ado, we quickly move into UTME questions. Yes, UTME questions on indices, and we try to use the law to solve expressions involving indices. Then subsequently, we move into what we call exponential equation. But for now, it is time to solve the first 7 questions we have here. They are all UTME past questions. We quickly use the laws to solve them. So moving on, let's quickly look at the first question. The first question talks about 5 raised to the power of x, 5 raised to the power of x times 25 times 25 raised to the power of x minus 1, all divided by 125 x raised to the power x plus 1, 125 raised to the power x plus 1. Now, there is something I need you to always flow with when it comes to dealing with expressions involving indices. You have to think of what we call lowest common base. Lowest common base. Now, looking at this, 5x remains 5x times 25. You look at it, it's something that we can break down further. So this means 5 raised to the power of 2, everything raised to the power x minus 1 into bracket x minus 1. But this 25 means 5 squared. And 125 here means 5 raised to the power 3, as 5 times 5 times 5. 5 times 5 times 5 is going to give you 125 into bracket x plus 1. So what you invariably have here is 5 raised to the power of x times 5 raised to the power 2 times x, 2x minus 2. And what you have here is 5 raised to the power of 3, x plus 3 if you expand using 3. So invariably what you're going to have is multiplication law. Look at law 1. When it is multiplication, you sum up the index or the power. So this here will mean 5x plus 2x minus 2. And this here is going to mean, when it's division, minus 3x plus 3. Take note, because this is a compound power. This is a compound index. You cannot write this as minus 3x plus 3 without a bracket, because the minus must have an effect on everything on the inside here. But when you write this, the minus sign, the negative sign, will not have any effect on the plus 3. So basically what we have here is this, since the base looks all the same, that's what we mean by common base. Okay, so this means 5 raised to the power x plus 2x minus 2 minus 3x, because minus times 3x minus 3x, minus times plus 3, that's minus 3. So we have 5x, 2x, 3x, x plus 2x, that's 3x, 3x minus 3x. So this out. 5 raised to the power minus 5, that is the answer, or 1 divided by 5 raised to the power 5 as negative index is going to give us 1 over. So that ends the first question. Moving on to question 2. The question is 1980, question 30. The result of dividing this expression here, this term, by this other term, that's x raised to the power a divided by x raised to the power b, all close bracket, raised to the power a plus b, as you can see on your on the board. Now the thing is very simple. It simply means this divided by this, just the same way like if you say 5 divided by 2. So in this case, we'll have to deal with the numerator before we deal with the denominator. Now looking at this, what this means, according to division law, you subtract. So what this means is x a raised to the power minus b, a minus b, because of course the same base, close the bracket, a plus b. Then for this, you then apply your product power law. When you have a power in here and a power outside, what you do is you multiply. So what this means is x a minus b times a plus b. If you're very conversant with algebra very well, you must have you should recall what we call difference of two squares. Difference of two squares goes that if I have x squared minus y squared, for example, it should mean x minus y. It should mean x minus y, x plus y. Let us expand. X times x, x squared, x times y plus xy, minus y times x minus xy, minus y times plus y, minus times plus minus y times y, y square. So what that means is that plus y minus xy, I'm having xy, I'm going xy, I'm going to end up with x squared minus y squared. So what difference of two squares is telling us here is that when we expand, we are going to have one of the expression as negative subtraction and the other as positive. So for me to have a minus b, a plus b here, that means x is a square minus b square. A square minus b square. That is what I can arrive at for the numerator. Now let's move over to the denominator. So divided by, this is x a plus b. Then division law states you subtract minus a minus b, because it's a compound exponent or compound index. You have to bracket it. All raised to power a square over b. All raised to power a square over b. So what this means is that x a plus b minus a, minus times a is minus a, minus times minus b is going to give you plus b, plus b. So that in this case, plus a minus a, this out. All raised to power a square over b. So that what I have, b plus b, that's x raised to power 2b a square over b. So what this means is x raised to power 2b times a square over b. B takes out b. So I'm left with x 2a square. X 2a square. So what I have is x a square minus b square. So I can write that out as x a square minus b square divided by x 2a square. Now the same base, so that's still division law. That's the second one there. That's going to mean x a square minus b square minus 2a square. So a square minus 2a square. A square is the same thing as 1a square. A square minus 2a square, that's going to give you x raised to power minus b square minus a square. I could leave my answer this way so that I have, okay, I have to expand. There is a minus here, there is a minus here. So x factorize minus, and then you're left with b square plus a square. You know why? Minus times b square will give you minus b square. Minus times plus will give you minus a square. So minus here is going to, the negative sign here is going to be 1 over. Okay, moving on to the next question. This is what we have. That's a 1981 question, question 26. So when you look at the sequence 79, 80, 1981, 83, 84. So these are, when you say indices, expressions involving indices, it's something you're going to get. So the best approach is always to expect it in your exam and prepare towards that. So let's quickly approach, let's take care of this question. Okay, what we have here is this. Now, looking at everything we have here, let me quickly point out here that imagine I have h raised to power 2. H raised to power 2 is 64. So I need you to know that since I have 8 here, 8 means 2 times 4, all raised to power 2. If I say 2 square times 4 square, 2 square is what? 16 times 4 square is what? 4 square is 2 square is 4. 4 square is 16. 16 times 4 is still 64. That is to tell you that, look, I could break 6 down and say 2 times 3 if I want to. But for now, let's just flow. Also, 6 raised to power 2n plus 1 will mean, for me to have a plus here, that means this must have been 6 raised to power 2n times 6 raised to power 1. 6 raised to power 2n plus 1, that's what it will give you. So times 9 raised to power n times 4 raised to power 2n. Or rather, okay, let's leave it this way. Now, all divided by, this by the way, all divided by 18 here could mean 3 times 6. Then you distribute the n times 2 raised to power of n. Or we could go 2 times 9. Let's go 2 times 9. We could go 2 times 9. Then we have 2 raised to power n here times 12 will mean 2 raised to power n times, so 2 raised to power 2n times 6 raised to power 2n. I'm beginning to see patterns that I'm okay with. So in the course of working out something of this nature, you keep in mind what you have as your numerator and what you have as your denominator, so that you work in such a way that you can cancel out. In this case, for example, this can take out this. Yes, that's it. Here, okay, the 4 I'm having here, I could change the 4 to 2 raised to power 2. Then I have 2n on the outside, so that 2 times 2 will mean 4n. 4n. So when you look at it, n plus 2n, you're going to have 6 raised to power 1 times 9. 9 raised to power n can take out 9 raised to power n. 6 raised to power 1 is what I'm left with, times 2 raised to power 2n times 2n, that will give you 4n. And then what you have here is 2 raised to power n plus 2n, that will give you 2 raised to power 4n. So this will be out. I'm left with 6 raised to power 1, which is still going to give me 6. So that ends that. It's just a case of you knowing how to work in such a way that the numerator can take out the denominator. Yes, moving on. Yes, moving on to the next question. This is 1983 question 42. We have cube root of 27a raised to power minus 9 divided by 8. Of course, when you look at this, you can just decide to separate things. This cube root is for all of the variables, and the constant on the inside is for all of the terms inside. So inside of the cube root. So the best approach is, okay, cube root of 27 times cube root of a raised to power minus 9, a raised to power minus 9, all divided by cube root of 8. Cube root of 27 is 3, because it means you can say 3 times 3 times 3, you get 27 times. I cannot find the cube root of a. So what I'm going to do is I'm going to bring the 3 back. For 3 to be here, this must mean a raised to power minus 9 divided by 3. A raised to power minus 9, because it was this 3 that has gone backward to form the cube root. Just like what we said there, the denominator always form the root. So I am bringing the root back as a denominator now. Now cube root of 8 is 2. So that what I have is 3 over 2. Now 3 here is 1, 3 here is 3. So that what I have is a raised to power minus 3, and that will mean I could leave my answer as 3 a raised to power minus 3 divided by 2, or this will mean 3 over 2 times 1 divided by, because of the negative index here, that's going to become a raised to power 3. 3 times 1 is 3 divided by 2a raised to power 3, because 2 times a cube will give you a cube. So my answer could be this and my answer could be this, depending on what you have in the option. So moving on, we have another question. This is 1984 question 14. Now you're seeing subtraction here, you're seeing subtraction here, and then you begin to look at it as though, are we going to subtract the base? No, that's not how we're going to go about this. in this situation, it's just a case of looking well. You cannot subtract this. You cannot subtract this. So I'll leave it as it is, 3 raised to power n minus 3 raised to power n minus 1. But coming to the denominator, I have 3 raised to power 3 here. 3 raised to power 3 is 3 times 3 times 3. 3 times 3, 9. 9 times 3, 27. So I have 27 for the term I have here, and I also have 27 on this side of the denominator. So it means that what is common to this side and this side is 3 raised to power 3. Then I'll be left with 3 raised to power n minus 3 raised to power n minus 1. So what I have done here is to factorize, to make out of a bracket 3 raised to power 3. 27 here is the same thing as 27 there is the same as 3 raised to power 3. So that what I have is at the numerator, 3 raised to power n minus 3 raised to power n minus 1 is the same thing with what I had here. So this out. So I'm left with 1 divided by 3 raised to power 3, or 1 divided by 27. That is my answer. Moving on to question 6. This is what we have. That is for the year 1988, question 8. We have 8 raised to power 1 over 3 times 2 raised to power 5 times 2 raised to power 5 raised to power 2 over 3 divided by 10 raised to power 2 over 3. Of course, this is indices. If the base are not looking the same, then you cannot multiply them together. So what you have to do is you work in such a way that you imitate the numerator, you use that to imitate the denominator, or you use the denominator to imitate the numerator. So will you just try to break this down? Of course, 8 here means 2 raised to power 3, or raised to power 1 over 3 times 5 raised to power 2 over 3, as I cannot break down 5 further. Then for 10 means 2 times 5, all raised to power 2 over 3. And this is what we're going to have, 2 raised to power 3 over 3. Of course, product power law, you expect 3 to multiply 1 over 3 times 5 raised to power 2 over 3, all divided by, now having 2 and 5 here, this means 2 raised to power 2 over 3 times 5 raised to power 2 over 3. That's what we have for now at the least. So that what we have here is 3 over 3, that's 1. Okay, so what I have is 1 minus 2 over 3 times 5 raised to power 2 over 3 and 5 raised to power 2 over 3, definitely out. So 1 minus 2 over 3, that is going to give you 2 raised to power 1 over 3. You know, if you say 1 over 1 minus 2 over 3, you should know that it will give you 2 over 3. If you don't understand how we got 1 over 3, just go back in time and check our videos on a fraction, our lecture video on fraction. So that ends that. So I have 2 raised to power 1 over 3. So this is my answer, or of course the denominator will always form the root, cube root of 2. That is our answer. So that ends that. Then moving on to the next question, question 7. Question 1989, question 5. The thing is, for your UTME, you are definitely bound to have question on indices or exponential equation. That's a must. It's something you cannot escape. So I will take care of indices now, and then in the next lecture video we'll take care of exponential equation. So let's move into this question. We have cube root of 64r raised to power minus 6. So the best thing is to just separate things. Okay, cube root of 64. Meanwhile, of course, we have a 1 over 2 here, raised to power 1 over 2. Okay, cube root of 64, that's 4 times 4 times 4. So that's 4 raised to power 1 over 2. Okay, times r raised to power cube. You're looking at cube root of r raised to power minus 6, everything raised to power half. Of course, if this cube root comes here, it becomes r raised to power minus 6, and then 3 will be, then this will be 1 over 2. This 3 is coming down here, divided by 2 times 3. Yes, 3 is coming down here. So what you have is 2 times 3 will give you 6. So the 6 invariably will take out the 6. So that square root of 4 here is going to give you 2. And then for this, what you're going to add is r raised to power minus 1, as 6 are taking out 6. I'm left with a minus 1. So 2 times r raised to power minus 1. So I have my answer to be 2r raised to power minus 1, or this r here could mean 2 times 1 over r, and that will give me 1 over 2. Sorry, that will give me 2 over r. Either this or this is very correct. So that ends that. Okay, moving on to question 8. We have another question. We're told to simplify this terrifying looking question, but it's nothing actually. That's for the year 1989, question 27. Okay, now looking at this question, I want to solve the numerator separately and I want to solve the denominator separately. Now, trying to look at the numerator there for question 8. If we decide to deal with the numerator, first, yes, that will be, I have x here, now I have x, but because I have a negative index here, that's going to be times 1 over x plus 1 all raised to the power of half. And of course here, that's minus x plus 1 all raised to the power half. Okay, at this point, it's looking like there is nothing much I can do, but still dealing on the numerator, that's going to be x over x plus 1 all raised to the power half minus x plus 1 all raised to the power half divided by 1. So this is dealing with my numerator. Okay, the LCM here is x plus 1 all raised to the power half. X plus 1 all raised to the power half. In x plus 1 all raised to the power half, that will be 1. 1 times x minus 1 in x raised to the power, x plus 1 raised to the power half times this. So you're looking at, let's say, x plus 1 raised to the power half times x plus 1 raised to the power half. You know why? 1 in x plus 1 raised to the power half is going to give you x plus 1 raised to the power half. X plus 1 raised to the power half times this. Okay, it's just like me saying, imagine I have a raised to the power half times a raised to the power half. That will mean a 1 over 2 plus 1 over 2. Half plus half will give you 1. So knowing that fully well, this will mean x minus half will give me 1. So that's x plus 1 raised to the power 1. That's what it means. Divided by x plus 1 all raised to the power half, 1 over 2. So that what this means is minus, so this will mean x minus x plus 1. Sorry, minus times x, this x is here, minus times x minus x, minus times plus 1 will give you minus 1, all divided by x plus 1 all raised to the power half. Okay, so that what I have here, this out plus x minus x out. So I have minus 1 divided by x plus 1 raised to the power half. I could leave my answer this way. That's what I have for the numerator. And mind you, I still have my denominator. So this is going to be divided by, if I bring in my denominator, divided by x plus 1 all raised to the power half. So this will mean minus 1 divided by x plus 1 all raised to power half times, this should turn upside down, 1 over x plus 1 all raised to power half. This times this, minus 1 times minus 1 ultimately is going to give me 1. But in this case, minus 1. But x plus 1 all raised to power half is the same thing. A raised to power half times a raised to power half, I'm going to get a raised to power 1. So I'm going to get x plus 1 here. So having this is my answer. Minus 1 divided by x plus 1. Look at it very well. So it's something very direct. Once you stick to the rules and you know a bit about your algebra, then it's something you should be able to flow with. But don't forget, if you have any indices question you've been battling with in the course of your preparation, don't hesitate. Check us out at the 300plusacademy.com. The first thing you're going to see on that website is a WhatsApp group for various people preparing for various exams come 2024. Then you can link up with us on WhatsApp and send to us, of course, all those difficult questions you're having. If you need more clarity on this, you can always get to us and ask questions. You can also comment on this lecture video and we will be glad to attend to you. Remember, the reason why you have 300 plus academy is purely exams tutoring the right way so that you ace your next exam. Okay, moving forward. So moving forward, we were told to simplify this. This is 1990 question 11. Okay, ordinarily this should mean 1 divided by 1 over x divided by 1 divided by 1 over y, everything raised to power minus 1. Okay, so this will move up because it's more like I have 1 divided by 1 over x. So that will be 1 times x over 1, so that I have x here divided by, this is 1 divided by 1 over y. It becomes 1 times y over 1. So I'm going to have y, everything raised to power minus 1. So this means x over y, everything raised to power minus 1. And that should give me a minus index, should be 1 over, that's a negative index, x over y. And that should turn upside down. That should become 1 divided by x over y. That should be 1 times y over x. So my answer here is y over x. That is my answer. Very direct. That is talking about question 9. Yes, moving on to the next question. We were told to evaluate this. This is 1991 question 25. We were told to evaluate this. All we just need to do is stick with the basic laws of indices. I am seeing a negative index here, so that's going to be x squared. This negative index here affects, of course, the expression I have in the bracket here. That is x squared minus 1. Of course, this will mean 1 over x squared minus 1 all raised to power half minus, what I have here is x squared minus 1 all raised to power half. So that, okay, this is more or less going to multiply this, so that what I have is x squared over x squared minus 1 all raised to power half minus x squared minus 1 all raised to power half. all divided by 1. Of course, the LCM here is x squared minus 1 all raised to power half. X squared minus 1 all raised to power half in x squared minus 1 all raised to power half. That will give me 1. 1 times x squared. 1 in x squared minus 1 all raised to power half times x squared minus 1 all raised to power half. Now look at it very well. I have said this before. If I have a raised to power half times a raised to power half, that's a raised to power half plus half. Half plus half will give you 1. So this times this, that's half plus half. So that's going to mean minus into bracket x squared minus 1 all raised to power 1, which is inconsequential. So if I expand with this negative on the outside, that's x squared minus x squared plus 1 all divided by x squared minus 1 all raised to power half. This out. So that what I have is 1 over x squared minus 1 all raised to power half. And I'll be correct. Yes, this is, I could leave my answer this way. Let's see the options that I have in that question. I just decided not to. Okay, I could leave my answer this way, as that is option D. At the same time, since I have 1 over means a negative index, so I could say x squared minus 1 all raised to power minus half, and I will be correct whichever way you go. If you go this way or this way, that is correct. So that ends question 10. Moving on to the next question. That's to the next question. That's question 11. Okay, looking at what I have here, I must begin to think in terms of breaking the number down into simple forms. So when I have 81, I'm thinking 3 raised to power 3. No, sorry, 3 raised to power 4 will give me 81. All raised to power 3 over 4 minus 27, that's 3 raised to power 3, all raised to power 1 over 3, and the outside 3 times 2 raised to power 3. Of course, what I have here is more or less like 3 raised to power 4 times 3 over 4, where 4 is going to take out 4. Take away 3 raised to power 3 times 1 over 3. 3 is going to take out 3, all divided by 3 times 2 raised to power 3. So I'm going to be left with 3 raised to power 3 minus 3 raised to power 1 divided by 3 times 2 raised to power 3. Of course, this is not a multiplication or a division. So what I'm going to do, 3 raised to power 3, that is 27. 3 raised to power 1, that is 3. All divided by 3 here, this is 3. 2 raised to power 3, that's 3 times 8. So what I have here is 24 over 24. And therefore my answer is 1 for that question. I was told to evaluate, so that I have done. The answer there is 1. Nothing too difficult in that. Moving on to the next question, that is year 2000. Yes, year 2000 question 2. And we have something very direct to solve there. So moving on to question 12, this is what we have. So the best approach here is to begin to try to break things down. And what I'm looking at here, for me to have a plus, that's 3. For me to have a plus here, that must have been 2 raised to power n, and then 2 raised to power 1, minus, I have 4 here, that's 4, and then this must have been 2 raised to power n divided by 2 raised to power 1. That is in dealing with the numerator, and of course, that must have been 2 raised to power 1 is 2, 2 here 1, 2 here 2. So that what I have is 3, that's dealing with the numerator, dealing with the numerator. So what I have here is 3, and then I have 2 raised to power n, 2 raised to power 1 minus, this is 2, that is 2 raised to power 1, 2 raised to power n. Of course, it's looking like this and this are common to the two terms. So that's looking like, okay, I'm going to make 2 raised to power n, and then 2 raised to power 1 out of the bracket, so that I'm left with 3, and nothing here means 1. Yes. So that this times this will give me this, and this times 1 will give me this. So this means 2 raised to power n, 2 raised to power 1, and 3 minus 1 here is what? 2. So that's what I have for my numerator. Okay, working on my denominator now. On my denominator, I have 2, this should mean 2 raised to power n, 2 raised to power 1. Of course, having this, that's why we have 2 raised to power n plus 1 minus 2 raised to power n. So if I look at what is common to this side and this side, that's 2 raised to power n, I make that out of the bracket, 2 raised to power n, and what I'm going to have, if 2 raised to power 1 is 2 minus 1. 2 minus 1, that will be 2 raised to power n, 1. So this will give me 2 raised to power n. So bringing the numerator and the denominator together, I have 2 raised to power n. 2 raised to power 1, of course, is 2. And then I have another 2, all divided by 2 raised to power n. This out, 2 times 2, that will give me 2 squared or 4. Any of this is just correct, and that is that about that. Nothing special. It is just about staying with the rules and doing things the right way, knowing that when to reverse what you have here. For me to have n plus n, that means that must have been n a raised to power m times a raised to power n. So that ends that. And so it goes. Next question, question 13. That's for the year 2002, question 2. Okay, you have this here, and we're told to evaluate without using tables. Okay, 3 for the 3, that's going to mean 7 raised to power 7 times 7, 49, 49 times 7. So that's 7 raised to power 3. Mind you, I have 1 over 3 on the outside times. This is going to be 1 over 0.14 to decimal, that is 14 over 100. Okay, and this is times 1 over 25 all raised to power half. Okay, so normally 3 would have taken out 3, so I have 7 times, this will turn upside down, 100 over 14 times 25 raised to power half here means 1 divided by square root of 25, so that what we have is 7 times 100 divided by 14 times 1 over 5. So 7 here 1, 7 here 2. So the answer here is 10. 100 divided by 10 is 10. Quite direct and simple. And then to the last question we have, at least for today, is question 14. So moving on to the last question, that's 2006 question 35. This is what I have here. To have a minus here, that is to have 1 over 25 raised to power half times 27 raised to power 1 over 3 plus 121. Okay, this is going to be 1 over 121 all raised to power half times 1 over 625 all raised to power 1 over 4. So dealing with this, this will be 1 over square root of 25 times square root, cube root of 27 plus 1 over square root of 121 times 1 over fourth root of 625. So 1 square root of 25 is 5. This 1 over 5 times cube root of 27, that is 3, plus 1 over 11. Square root of 121 is 11 times, what is the fourth root of 625? It means a number that if we multiply with itself 4 times, it's going to give us 625, and that is 5. See? 5 times 5 times 5 times 5 times 5. 5 times 5 times 5 times 5. 5 times 5, 25. 25 times 5, 125. 125 times 5, that will give you 125. That's 625, sorry. So this is what I have here. So this is going to give me 3 over 5 plus 1 over 55. LCM here is 55. 5 in 55, 11. 11 times 3, 33. 55 in 55, 1. 1 times 1, 1. So the answer is 34 over 55. That is my answer. And that ends that about indices. Remember, if there is any of the question we've answered you don't understand, just check in the description of this lecture video. Check us out on 300plusacademy.com. Link up with us on WhatsApp, and of course let us have your question or your comment right after this video, so that we can tend to you. Also, if you have any question that has to do with indices, do not hesitate to let us have it, and we sure will get that solved for you. Next on the list of things here is going to be exponential equations. Do not forget, turn on the notification bell, subscribe to this channel, comment, let us know what you think about our lectures, and I tell you, we will receive those comments and work with them. For myself and the team here, it's bye for now.